Good morning and welcome to Arithmetic Lesson 133. Today we're going to go over some decimals. You should have taken your test yesterday. We are going to go over some decimals and make sure that you know what goes on the top and what goes on the bottom. Okay, so when you see 2.2, you say 2/10. It should look like that. 2/10. You tell me the fraction for this decimal. Are you ready? Here we go. 5/10. Okay, make sure you're saying them along with me. 8/10. Do you see there's only one place value, one spot, and if there's only one spot, it's called tenths. So it would look like this, 8/10. Here we go. This is a tricky one. 1 whole. If I was talking about tenths, what would be the fraction? The bottom number would be 10. What would make it 1 whole? Let's see if you know. 10/10. Very good. Don't forget, 1 whole would be 10/10. Here we go. 21/100. That's right. There's 2 place values, so we're working with hundredths. How do you say this one? 31/100. Very good. This one, 41/100. Again, 2 place values. That means there's 2 zeros on the bottom with 100. Okay, 2 zeros, 2 place values after the decimal. Here we go. Again, 2/10, 5/10, 8/10, 10/10. Okay? Okay, boys and girls, these flashcards are going to have a 0 that you need to pay attention to. Remember that on the bottom of your fraction, there are 3 zeros. That means that there needs to be 3 place values, but you only have 2 decimals here. Remember that you need 3 place values. So if you do not have 3 digits, you need to put a 0 in front. Watch what happens. 0, 31. The decimal goes in front. So again, 3 zeros, 3 place values. Not 3 digits, so we need to put a 0 in front. So we say that this is 31 thousandths. Okay, here we go. Let's try this together. 1/100th is 1/100th. 2 place values, because again, the hundredths place is 2 place values. Therefore, you get 2 place values and your 0 goes at front. Okay? Here we go. I'm going to go a little bit slower. Are you ready? Ready? 3/100ths. Think about that place value. 1/1000ths. 2/1000ths. 3/1000ths. Do you understand? Let's mix them up. All right. I will show you the fraction first. 3/1000ths, 0.003. Very good. 11/1000ths, 0.011. 200ths, 0.02. You got it? Okay, good job. Boys and girls, at this time, I want to make sure that you have completed your speed drills. I know that you may not have done it each day on the day that it was due, so go ahead and take out your speed drill paper. Go ahead and time yourself. Take out a timer. Look at the time. Do your best. Remember that you don't have to finish it, but you do have to do the best you can. You need to make sure that you're not worried as much as the time as getting them correctly. You want to make sure that each one that you do get to, you do correctly. And let me know your scores. Take a screenshot of it. Let me know. Remember, on your screenshots, I've been seeing a lot of the screenshots where I see more of the background than I do of the picture. So you want to make sure that the camera is only seeing the piece of paper that you are taking a picture of, okay? When you take that camera, you take a picture only of that paper. Don't get anything in the background, only of that paper, okay? So go ahead and take your speed drill now. So boys and girls, I want to talk a little bit today about something that you might have at home. Maybe mom and dad keep it in the bathroom. Let's see if you can guess what it is. So it's kept in the bathroom. You stand on it. Maybe mom and dad look down and say, "Oh no!" Maybe you've been on one if you go to the doctors. Do you know what I'm talking about? A scale. Well, today I'm going to talk about a scale, but I'm not going to talk about the one that you weigh yourself with. Not that one. I want to talk about a scale in drawings and on maps. Maybe you've seen a map like this before, and you have thought to yourself, well, the state of Florida doesn't look that tiny, does it? If you think about it, no, we don't even look that tiny. But we could not put that much things on a map. This is a representation of the state of Florida or of the United States. So they had to what we call scale down that picture, okay? If you took a picture from out of space, it would look like this, but at a different scale. So we think about scales as a comparison, okay? If you compare 1 inch, if I draw 1 inch, that would equal to 1 mile on this map. And you know what? It is quite accurate. So if we measured our map from California to Maine, we get about 30 inches, okay? 30 inches. So if we put here 30 inches equals how many miles? Boys and girls, how many miles would 30 inches be? You would multiply 30 times 100. And when you did that, you'd get 3,000, right? Now, if you look up on Google, you will find that it is about, not exactly, 3,000 miles from Maine to California. So it's about right. It's very close, okay? It's very similar. And this is the way you would do a scale, okay? So our scale would be 1 inch equals 100 miles. So on your paper, let's take this down, boys and girls, and we will see on your paper, we have here on our paper bear with me for just a moment as I get this running for us. We have on our paper, remember we're on lesson 133, we have a scale drawing. It's not as fancy as my map, but a scale drawing of a neighborhood, okay? It says the scale drawing of a map is used to show long distances in small amounts of space. 1 inch can represent many miles, just like our map represented 100 miles. So it tells you the scale here. It's almost like your key on a map. Your scale says 1 inch equals 1 mile. So if you have a ruler at home, which I hope you do, but if you do, you're going to measure from the post office to the store. From the post office to the store. When you do that, you should get about 9 inches. Okay, 9 inches. From Ted's house to the store. From Ted's house to the store. Now, you say, but Mrs. Bess, there's something in the middle. How would you do that? First, you have to measure to here. First you have to measure, where's my yards? Okay, from here, which is 14, and from here, which is 9. And what do you have to do to those two numbers? Add them up, right? How about from church to the post office? Here's church, here's the post office. You're not going to take a shortcut. You want to see from here to here, from here to here, from here to here, okay? Make sure you add them up. It's not so hard, just take some time. On the bottom, we are going to review just a few of your problems here. Let's put this ruler down. And let's try this together. Again, you have your paper. I can make this one a little bit bigger. Hopefully you can see that now. And we have 97 and 3/11 plus 23 plus 46 and 4/22. Again, you have this paper. Can you add or subtract fractions with different denominators? No, you cannot. Let me stop there. Do you remember the question that I gave you the other day? Can you multiply fractions with different denominators? That answer is yes. I'll get back to it. Make sure you know the difference. Adding and subtracting, you need the same denominator. Multiplying, you don't need the same denominator. Okay, 3/11, 4/22. Our new denominator will be 22. This stays the same, and this changes to multiply by 2, and you have 6. 6 22s plus 4 22s equals 10 22nds, 7, 10, 16, carry the 1, 1 plus 9 is 10, 12, 16. That's your answer. Circle it and keep it as neat as you can. 19 and 2/5 minus 16 and 3/10. 2/5 minus 3/10 you cannot do. You must, when you're subtracting fractions, you must have like denominators. We picked 10. This is 4, and this is 3. 4 minus 3 is 1. 9 minus 6 is 3. 1 minus 1 is 0. Final answer. Go ahead and finish these. Remember, adding and subtracting fractions, you need the same denominator. I'm going to move on. You're going to do that during your seat work. Solve these problems. I'll bring it down just a little bit. Okay. Solve these problems. Michelle bought 6 yards of cloth at $1.50 per foot. How much did the cloth cost? Well, remember your story problem keywords. Keywords. Michelle bought 6 yards of cloth at $1.50 per foot. How much did the cloth cost? Per foot. Your per foot means 6 yards. We have to convert. We want our answer to be in feet. We have 6 yards. And we want our answer to be in feet. So 6 yards equals how many feet? We do our steps. We say that yards is larger than feet, so we multiply. And our special number is, there's 3 feet in 1 yard, so 3 is our special number. And we multiply 6 times 3 is 24. Now, that's just the answer to this. We still don't know if it's $1.50 per foot. How much does it cost? We have to do what? Multiply by 24. $1.50 times 24. You can do that math as you wish. The next one. Mr. Montoya drove for 7 hours at the average speed of 59 miles per hour. How far did he travel? Per hour. Average speed was 59 miles an hour. He drove for 7 hours. And you can get your answer. Okay? Go ahead and complete the rest of the review on the back as well as some homework. And we will see you back on Monday. Have a great day.